And Honorable Dr. Rashid, I wish to thank everyone for being in this presentation. Uh, I work for a company called Wärtsilä, and the topic of my discussion is seeing sustainability as an opportunity, which we are in the business of energy, so what I will concentrate is on the power sector, how it is evolving and how it is changing, in the coming future. Before we start, I wanted to say that the power system that we have today is delivering what it was supposed to do. It is providing energy for the economies, for the society, but there are new challenges being faced if we have to reduce CO2 emissions, if we have to decarbonize, use renewables into the system, then will the present power system, stand the test, which is what I would like to explore a little bit with all of you. As I told that the energy landscape is in transition, and we in Wärtsilä, we feel that we are slowly moving towards a society where 100% of the energy needs in the world will be provided by renewable energy sources. Two of the important facilitators to this, to a 100% renewable society, will be a power system which is very flexible, which is not base load and inflexible, and the other is the energy storage system. So the path to this transition and a sustainable transition is, the stages that we faced are that the reality is that renewables are getting cheaper. So as we progress, technologies are improving, and renewable energy is getting cheaper. The tipping point will come when the existing thermal capacity will be replaced with flexible generation. By thermal energy, I mean, the existing coal plants, which still contributes around 40% of the energy needs of the world. And then a stage will come when renewables will become the new base load. So they will start to provide the base load into the system, and at some point, 100% renewable energy will be achieved, and which will provide for all the seasonal backups, daily energy variations will be managed with storage. So there are different types of flexibility requirement for such a society and for us in the world. The daily variations will be handled by energy storage, which is basically second and minute level variations. And of course, also as the prices of battery energy storage system reduces, we will also have daily energy shifting. And then the weekly balancing of energy will be provided by flexible thermal generation, and the seasonal by shifting large amounts of solar energy from summer to winter, and upcoming technologies like power to gas and existing LNG infrastructure. So how is renewable energy changing the market? You can see how the price of renewable energy is decreasing, and already we see now that the levelized cost of electricity for onshore wind and PV is less than combined cycle and coal, much less in China. So this trend is continuing, and as we see it going forward, by 2030, 2040, this will be almost half of the conventional power generation. The market outlook, as you can see, we still have a long way to go, but already the contribution from solar and wind is substantial. Almost 50% of the installed base in the world is through conventional, and this has happened not in many years. I would say maybe 6, 7, 8 years that we have reached this stage. And you can see the base load inflexible generation coal is slowly starting to reduce. And the lighter blue lines little bit increasing, and then of course the flexible generation, which is the top bar in gray, which is substantially increasing because that is what is needed to compensate for the variation because solar energy, it varies during the day, the wind condition changes, so that is being met by the flexible generation. What are the changes happening? This is a typical load curve, 24-hour load curve that you see. And as you might all know, that power system is the largest man-made dynamic system. And it is really, complex system. The intermittency of wind and solar power represents the biggest challenge to change. And as the solar comes into the system, okay, let me go a little bit back. As you can see, earlier days, there was a base load which was continuous. So all the inflexible generation, the power requirement was from the base load. But as solar comes into the system, you see that the base load generation is not continuous. There is a change in that. And as the wind comes, you see almost the base load has gone. So basically, whatever existing assets are there, they have to run, they have to cycle, they have to ramp up, ramp down, not running at 95 to 100% load, which is their sweet spot for efficiency. So where did the thermal baseload go? And basically what has happened with this thermal baseload going, new investments are required in the power system, and that is actually the flexibility in thermal generation that is